day to everyone. So this week we're going to continue our lecture for SECI2143 Probability and Statistical Analysis, and we're going to go into chapter 4, that is Introduction to Probability. Okay, so this video will discuss the part 1, that is the overview of probability. Okay, so what is probability? Okay, so if you guys would be able to recall, okay, last semester you have already been introduced to chapter 3 part 4, that is the probability theory. Okay, so probability is a systematic study of uncertainty. Okay, means that we wanted to measure how confident are us in an event when something happens. Okay, so example of activities that we can have here is just like rolling a dice. Okay, so when playing a game, so what is the probability for us to get 2 6 on our dice? Okay, on each of our die. Okay, and then when you toss a coin, so what's the probability for you to get both coin, let's say you have 2 coins, both coins are showing head. Okay, and then when you select a card from a deck, so what is the probability that you will get a certain card that you want? Okay, usually magician, they have this type of activities or type of magic. Okay, because and if they are able to show the card that you have guessed, they have a very good chance of probability on knowing the answer. Okay, so the first term that you need to understand or you need to remember is chance experience. So what is a chance experience? So chance experience is an activity or situation in which there is uncertainty about 2 or more possible outcome that will appear, or that we will get. Okay, that we will get. Okay, so an example of chance is, okay, when you play game, again, as I mentioned, when you play game, so what is the possibility that you will get both of the dice, okay, will get 6. Okay, and then what is the possibility if you flip a coin and it will land on heads? Okay, because for coin we have 2, head or tail. Okay, so this is what we call as a chance experiment. Okay, so what is the possibility on getting the certain result that we want? Okay, so the second term that you need to understand is sample space. Okay, in statistics, okay, usually, or in probability, okay, we always start our sentence with suppose. Okay, means that we wanted everyone to understand the situation. Okay, so suppose a 6-sided dice is rolled. So what are the possibility that that it will come or it will land in one of the side of the dice itself? Okay, so a sample space represent the all the possible outcome of our chance experiment. Okay, so the chance experiment here is rolling a dice or a die. Okay, and the possible outcome that we get is either it will going to land on 1, 2, 3, 4, 5 or 6. Okay, so this is what we call as a sample space. So for a sample space, usually we will use the curly bracket, okay, to represent. Okay, and you use S. So that is a symbol. So when we see this, then we are saying that this is the sample case of the chance experiment. Okay, so this is the sample space, the possible outcome from our experiment. All right. Okay, so another example of a sample space, if we have 2 coins. Okay, let's say if you have 2 coins flipped, so the sample space would be there's a possibility, okay, because for each coin is either head or tail. Okay, since we have 2 coins, so there's a possibility that we will get one coin will have, or both coin will have both heads being flipped out. Okay, so this is the first sample space. Okay, and another possibility that we're going to get from the outcome or from the result is the first coin is going to be head, okay, and the second coin will be tail. Okay, so this is coin 1, coin 2, coin 1, coin 2. And the third possibility is that the first coin will show tail and the second tail will show head. Okay, and the next possibility is that we're going to get both tail for each of the coin. Okay, so we have 4 sample space in this possibility, okay, in this situation. Okay, so this is one way that you can use. Okay, if it's a simple a decision or simple possibility, then you can just use a simple tree diagram to represent your sample space. Okay, that's one thing that you can do. All right. Okay, the next thing that you need to know or understand is what is an event. Okay, so an event is where we okay, before I go to that, okay, for the example here, okay, let me go to one so one by one. So the chance experiment that we have here, is the possibility of a car purchasing process. Okay, so we have the car might be bought by a male or a female, and the type of car that we have is hybrid and traditional. Okay, so we have this situation on a chance experiment. Okay, so for our sample space is the possible outcome that we might get from our chance experiment. So we might have, the first one is where we have a male who's purchasing a hybrid car. Okay, so this is the first sample space. The second sample space is when we have a male buying a traditional car. Okay, the third sample space is when we have a female buying a hybrid car, and another one is a female buying a traditional car. So we have 1, 2, 3, 4 sample space in this chance experiment, in car purchasing chance experiment. Okay, so now let's say we are only interested in one outcome, that is the possibility that a hybrid car is being purchased. So this is our interest. Okay, a possibility of a hybrid car that is being purchased. So what are the possible outcome that we can get from here? Okay, so from the sample space that we have, we notice that there is 2 possibility, that is either being bought by a male or it is bought by a female. Okay, so it's bought by a female. So we have 2 event. The event is buying a hybrid car, where we have 2 possible outcome of that event, is either being bought by a male and being bought by a female. So when you have this individual outcome, okay, so we call it as an event. Okay, an event is a part of the sample space, only that we specify what do we want or what type of event that we are most interested in, meaning that we are not interested in all of the sample space, but only on a certain event that might likely happen from our sample space. Okay, so it is an event is a collection of outcome from sample space. So we can say that to do probability, what you need is you need to identify the chance experiment first. Then you need to identify the sample, all the possible sample space. Then you might be interested on certain event that happens based on the sample space that we have. Okay, so you need to understand all this. Sample space, okay, and event is very important. Make sure you are able to differentiate between sample space and an event. Okay, okay. Another term that you need to understand when you understand your sample, what is the chance experiment, okay, the one that you wanted or you are interested to do, and then you need to know what is the sample space, okay. Chance experiment, then you know what is the sample space, then you know what are the event that you are most interested in. So these are how we can in a way calculate the possibility of what happens in the event, okay. So the first one is complement, not. Complement mean not, means that if you have already a certain event that you are interested to, what is the chances of the event that is not happening? Okay, you know the possibility, you might know the possibility of the event happen. Okay, so in that case, that you will also be able to know what is the possibility if the event does not happen. Okay, we call it a not. Okay, so how do we symbolize it? Is either using a bar, okay, or the apostrophe symbol, or the complement. So this is the most used symbol for a complement, okay. The certain event that how you assign the event, and then you just put a small c, okay, a superscript c there, okay. So another thing, another chance that happened for our event, if we wanted to know what is the chances if for event A or B happens. Okay, so we call it as a union, okay, symbolized by this, the big U, in a way, U, okay, because it symbolize union. Okay, we wanted to know if there are two event, you have a sample space, and then each of the sample in the sample space you have a specific event that you wanted to analyze. Okay, so you wanted to know what is the possibility to have A or B happen at the same time. Okay, it's or, it's denoted by or, so you need to remember or, okay, means union. Okay, the third one is you wanted to know what will happen if A and B happen at the same time. What is the possibility? Okay, so if you use and, so we say that is the intersection of two events, okay, and it's being denoted by this symbol, the and symbol, okay. It's actually the reverse of the U, so you need to remember. So this is in the way union. So this is and, okay, and. Okay, I think most of you guys have already been exposed with this, okay, especially in school. All right. So this is an example. Okay. So suppose a 6 dice is rolled. So this is our chance experiment. So this is our chance experiment. Suppose there's a 6 dice is rolled. Okay. So so in a way, our sample space is not being shown here, is either 1, 2, 3, 4, 5, 6. So this is our sample space. Okay, we might get it might land on 1, 2, 3, 4, 5, or 6. Okay, however, we are not interested in having, knowing the possibility of if any of this happen. Okay, what we wanted to see is what is the possibility that it will land on an even number. So this is an event. So the event that we wanted to know if it land on an even number. Okay, so if we will represent it on E. If you ask why E, in a way we say that this is to represent even number. Okay, an even number. So I hope everyone know what is an even number. Okay, even number, odd number. Okay, so this is the possibility for us to get an even number. Okay, so everyone know the possibility to what are the even number. So it's either 2, 4, and 6. So we have 3 possibility, okay, 3 possibility of having to get an even number, okay. So now, what is the possibility if we don't get an even number? Okay, so that means that we will, the possibility of not getting an even number is for us to get the odd number. okay, not landing. Okay, so for this one, we use the symbol even complement. Okay, so it's either one, so we choose the one that is not happen, not likely be happening, not an event that we are interested in. Okay, it might happen, but it's not an event that we interested in. Okay, and you need to remember when you when you add up, or when you sum the probabilities of the event, both event, okay, you will get 1. Okay, we'll see about this again later, okay, after this. All right, so this is complement. Okay, now based on our sample space, okay, so I just wrote it down again. So our sample space is, okay, so the first event that we were interested just now was the even number. Okay, let's say we are interested on another event, that is, what is the possibility that it will land on a prime number. Okay, I hope you still remember what is a prime number. Okay, maybe during the lecture later, I will ask, someone can answer me, what does it mean by a prime number. Okay, so the how you name your event is based on you. Okay, so just now this one we use E to represent even, and we use P to represent prime number. Okay, so for prime number is either 2, 3 or 5. Okay, 2, 3 or 5, that's an even number, that's a prime number. Okay, so we wanted to know what is the possibility if E or P happens. Okay, so we are saying that if, let's say, what the possibility of both of these might be happening. Okay, so the outcome that we will expect is it will land either on 2, 3, 4. 4 comes from even number, 3 comes from prime, 2 comes from both. Okay, 5 comes from prime, 6 comes from even. Okay, so we just put together all of the possible outcome that will happen if we get an even or a prime number. Okay, so this will be the answer. Okay, and then you make sure you use it. It's either you write it as E union P, okay, and your answer. Okay, so this is also accepted. Okay, usually for exams, if you have this type of question, okay, make sure you answer it using the symbol. Okay, don't try to avoid using this. Okay, so it's either E or P. Okay, what about intersect? Intersect is, again, let's say we are still interested in the same event, that is getting an even number or getting a prime number, but this time we wanted to say what is the possibility that the outcome that we have is an even and a prime number. Okay, so for this one we need to identify the event on this we need to find the outcome of the same event. Okay, so based from here we see that we have only one event that is the same for even and prime, that is getting the number 2, getting the dice 2. Okay, so this is what does it mean by intersect. Okay, union, we just put together all of the possible or the possibility outcome, but for intersect we need to choose only the same possibility. Okay, the same possibility or the same outcome that will happen. Okay, so for this one there's only one because we can find both. Okay, number 2 is an even and also a prime number. Okay, okay, so this is another example that we can use to see, okay, a Venn diagram. So this is also very famous. Okay, so the red one here, okay, the red circle is representing prime number. The green circle, okay, the green circle is representing the even number. Okay, so we know for prime number the possibility is that 2, okay, 3 and 5, and for even number is 4, 5, 4, 6 and 2. Okay, so the union, okay, if you want to go into union, is where you have the numbers in both circle, but for intersect is the numbers that is in between, that is in both side. Okay, that is even and prime number. Okay, and 1, why does 1 outside the circle? Because 1 is not an even number, and also it's not a prime number. So that's why it's outside. So any outcome that is not the event that we want, okay, remember, because for this one we only interested on even number and also prime number, so it will be the outcome will be outside of the Venn diagram, okay, outside of the circle diagram. Okay, so this is another way that how you can see complement, okay, both diagram, that is that is union. Okay, the middle one here, this is the complement. Okay, and here this is complement, this is I forgot, this is the intersect. Okay, sorry, so this is the intersect. Okay, and this one here, okay, this is the complement. Okay, anything that is outside of our circles, that is complement. Okay, so you just need to remember this. All right. Okay, now before this, okay, what we've shown here is how you actually identify the outcome of the event itself. Okay, so now we are coming to the probability. Okay, so when we are actually identifying the sample space and also identifying the event, okay, we are actually saying that the outcome of each of the event that happens, okay, are equally likely. Okay, it means that it has the same possibility of it will happen. Okay, just now when we had okay, when we had our dice, okay, so there's a possibility that we might get okay, there are equal possibility that we might get 1, 2, 3, 4, 5 and 6. Okay, so the possibility, so probability is the ratio of the number of outcome, okay, to the total number of outcome in the sample space. Okay, so now we are saying, okay, for example, we are saying here that there is a possibility, there is one possibility. Let's say we wanted to roll the dice only once, okay, one time only. Okay, so in that one time, there is one probability that we will get 1. Okay, so this is 1. Okay, and one probability that we're going to get 2. Okay, 1, 1. So there are actually 6. Okay, from our sample space, we have actually 6 probability. Okay. So we have 6. The total number of outcome based from here, okay, the possibility is 6. Why? Because we have 6 different outcome that might happen. Okay, so the probability of us getting 1, okay, getting 1 is only 1. Getting 1 is getting the number 1 is 1 over 6, because there's only one chance. We are saying that all of these have equal probability of only appearing once. Okay, only appearing once. Okay, so for each of these probability, for each of these outcome, for each of these outcome, we are saying there's a 1 over 6 chance of it will happen. for each of your for each of the event. Okay, so there's only one sex possibility because we are saying that it has the same it has equal likely the same possibility that it might happen. Okay, so possibility is being identified by getting the ratio of the favorable outcome that we want, okay, compared to the total of outcome in the sample space. Okay, so that is very important for you to know what is the sample space first. When doing probability, you need to know what is the sample space first. Identify the sample space first. Okay, for you, in order for you to get the lower value. Okay, then this one is what is the outcome of the event that we want. Okay, certain event that we want. Okay, meaning that 1/6 here is representing for us an event for us to get the number one dot. Okay, so it's 1/6. Okay, so we just go into another, we'll see again this in another exercise. Okay, so in probability, there are certain rules that you need to remember. Okay, so the first one is for a probability, the only values that we accept is between 0, the probability, okay, to 1. Means that if you get a value of 1, we are saying that this will happen for sure. Okay, 0 means that it will not happen at all. So if you get a value of 0, we are saying that it's not going to happen. Okay, and we are allowing the values in between 0 to 1. Okay, just like this one. Okay, 1/6. So there's the possibility of 1/6 on getting the dice to land and at 1. Okay, and the values of the sample space, when you add up all the values in our sample space, it will always give us 1. Okay, for example, just now for our dice, okay, having 1, 2, 3, 4, 5, and 6. Okay, so for all of this, we have only 1/6 chance of it's going to happen. Okay, so a sample space, when you add up all of this possibility of our sample space, you will get 1. You will get 6/6 equal 1. Okay, so a sample space sum or total of the sample space will always be 1. Okay. Okay. In an event where we have two situation that is disjoint, means that it's totally two different event. Okay, example just now, let's say for this one we wanted to get the what is the chance to get an even number, and this one is to get the prime number. When you add up, when you wanted to know what is the possibility of two different event, okay, happening, then you just add it up. Okay, you add it up. So for this one, you might get a value more than 1. Why? Because the first event probability, the highest number is 1. The second probability, the highest number is also 1. Okay, so let's say you have the first probability where it might happen is 0.6. The second probability that it might happen is 0.8. So the probability of both this event happening is 1.4. Okay, 1.4. Then for this value, we can it is allowed for us to have a number that is more than 1. Why? Because these two events are actually two separate events, two totally different events. Okay, so you might get a value that is more than 1. This is allowed. Okay, but the rules is it has to be totally two different event. Okay, example, this is the possibility that you get students wearing red shirt, and this is the probability of having students riding a motorcycle. So this is a totally two different event, okay, of maybe two different sample space. Okay, so that's why it is allowed to have 1. Okay, the result more than 1. Okay, the next one that we need to remember is complement. Okay, if you have a complement situation, complement must happen only on the same event. Okay, so when we have the probability of P, okay, this is the event that you want just now. Let's say you wanted to know the even number, okay, to get the even number, the dice to get the even number, and the complement of it, that is getting the odd number, okay. So the total of this, the probability and the probability of the complement event will always equal 1. Okay, so you just need to remember this. Okay, sometimes the question might not be straightforward. It might give you the probability of an event, okay, but then in another situation, it might be using the not E, the complement of that event. Okay, so let's say this value is not given. Okay, then in order for you to solve the problem, you need to get this value first. So how do you do it? Let's say this one, the value is 0.8, and this one is not known and 1. So you know that the probability of not E, okay, is 0.2. Okay, so this is something that you, let's say, because the question will be a bit tricky. It will not give, you will not be giving the probability straightforward. You might need to find it somewhere else. All right. Okay, so there are 2 exercises for this part. Okay, so exercise 1 and exercise 2. Okay, so we will discuss this exercise in our online class. So you need to make sure that you understand and please try it. Okay, so maybe we can just go through the exercise to help you to understand the exercise. Okay, so now the school council, exercise 1 for a school of math and science, they wanted to have 1 representative. Okay, from 5 academic department. We have biology. Okay, each of these departments are giving 1 representative. So 1 from biology, 1 from chemistry, 1 from mathematics, 1 from physics, and 1 from statistics. Okay. Now, the event that we want, the sample space. Okay, this is the chance experiment. So the sample space that we want, the chance experiment that we're going to observe is, we want 2 of these 5 representative students to be selected randomly, okay, for a student committee. So that means that from these 5 department, 1 student from 5 department, 2 will be chosen. Okay, so how do they make the decision? Is just by writing name in a paper and put it in a bowl and just drawing them out. So it shows that it is randomly selected. Okay, randomly selected. Okay, so answer the questions. One is, what are the possible outcome? Okay, you need to list out all the possible outcome, and already it has mentioned here, it should have 10 possible outcome. Okay, so you need to list it out. Okay, there's no need for you to when you do it, you might not need to repeat it. Okay, if they are repetitive, so you need to make sure that it's unique. It's all a unique outcome. Okay, so the second one is, it asks you what is the probability for each of the event. Okay, each of the event means that what is the probability that a biology and a chemistry student might be chosen. Biology and mathematics are chosen. Okay, so that is the possible outcome that we wanted to know. Okay, possible event. Okay, and then it will ask, what is the probability if the committee member comes from statistics? Means that out of all of our sample space, what is the probability that 1 student from statistics department will be chosen? Okay, and then the second question is the probability of both committee members come from laboratory science department. So what is laboratory science department? Okay, it's biology, chemistry, and physics. Means that both of the representative comes from these 3 department. Okay, so that's in exercise 1. We will discuss this in class. All right. Exercise 2. So for this one is about departmental store. Okay, so there are when a purchase is made online, so customer can select 4 different options. Okay, one is expedited overnight delivery, second expedited second business day delivery, standard delivery, and delivery to the nearest store for pickup. Okay, so the chance experiment that we wanted to do here is to observe the selected option, okay, the selected delivery option for a randomly selected online purchase. So what are the sample space for this? Okay, a customer can only choose one delivery option only. So what are the sample space? Okay, and then for this question, it already gives you the probability values. Okay, for overnight, it's 0.1, second day delivery 0.3, standard delivery is 0.4. So it gave you the probability for 3 of the sample space. Okay, so there's a clue there. I'm already giving you the clue. All right, so now you need to find possibility of randomly selected online select delivery to the nearest store to pick up. Okay, the one that the probability value that is not being given to you, so it asks you how to get the probability value. The second one is the probability that customer select from expedited delivery. Okay, so take note on how many expedited delivery that we have. The second one is the probability of a customer that choose either standard delivery or delivery to the nearest store. So we wanted to know what is the probability of customer choosing either one of these this delivery form. All right, so that's the question. Okay, so part 1 ends here. I'll see you in part 2. Okay, thank you.